Welcome to Engineer in the Making. Today, we're turning this into this. So for anyone who had an awesome childhood, aka Era 2000, they would know that this is Guitar Hero drum kit. Now for anyone who doesn't know, Guitar Hero was like the bee's knees of interactive gaming in, the 2000s era. We're talking every party you went to, people would be playing Guitar Hero, have the drums out, guitars out. I'm pretty sure there was even a microphone that no one even used. But what I'm going to do today is turn this into a working drum kit, an electric drum kit, one that you can actually play through some speakers. It's going to have a MIDI output that we can use to plug into a computer and essentially control the sounds. So let's take this into the workshop and get cracking. Alright, so before we tear this thing apart, let's have a little bit of a think about how the system actually works. Because I do want to make sure I can maintain its playability, so that if I do decide to have, like a flashback 2000s party, I can still crack this thing out and give it a go. So my understanding of how these things work is under each one of these pads, we're going to find a piezoelectric disc. Now a piezoelectric disc is essentially a little round device that when you apply pressure to it will output a voltage. So every time you hit, that'll detect a big spike and that'll actually send the command through the gain that says, hey, he's hit the red pad at this time. So what we want to do is convert that signal into a MIDI output, say via probably an Arduino over USB to the computer, and then we can have some software running on the computer that reads that in, that MIDI control, and can actually play a sound from speakers. So it's pretty simple. So let's rip it apart, see what we can find, and make sure that we can actually do this. So first things first, these legs have got to go. That's a bit more manageable now, isn't it? Alright, so as you can see, I've actually had to make some modifications to this in the past. The batteries, someone must have left them in there, and they essentially corroded. So I've had to strip those out, I drilled into there and soldered some wires onto the terminals and just put it out to my own little battery holder. So that's probably fine, that'll still work. We might try and fix that a little bit more legitimately if we can while we're at this. But let's start to try and crack this thing open. Alright, so it looks like we have some funky little hex heads in here, the torque screws. I should have something that can undo these. Oh, first go! So there we have it, boys and girls. So now I've got the cover off. It's exactly what I thought was going to be in here, which is awesome. So as you can see in here, we've got piezoelectric discs, so one under each pad. And actually in the cymbals, they must actually have their own inside there. We can maybe try and take a look in there in a bit. And then those just plug in via a little kind of headphone type cable. So what we're going to be able to do now is these two cables that are coming off each of these, we're going to be able to splice those, split them off so that we can still maintain them going to the control board that they've already been connected to. And then the other split that we do can go into the Arduino and then we can do some stuff on that. So, let's cut some wires. Okay, so here we have a little Arduino Uno. This is probably the main type of Arduino that most people use for projects. It's going to be a little bit tricky to fit this anywhere because it's a little bit big. So what I'm thinking... Okay, so what we're going to do now is try and find a spot for this Arduino Uno. So I'm going to try and fit it into this top section here, which is actually where all the buttons are housed for the game. So it's got the start button, the select button, all of that. If we can try and move this little unit here, which is what I think must send out some of the commands to the actual unit via the wireless connection, we need to move that maybe over to the left over here, and this little Arduino here can maybe try and sit in there, which I think would be ideal because it means we can cut a hole in the top here, which is where our USB cable can fit in. We'll also have access to the power, which will be right here, so I think that'll be a really good spot for it. So let's see what we can do. Let's get some of this over here. Pass it along. There's our problem. Alright, so we may not be able to move this board as easily as I thought without extending all these cables along here, because they're quite short. They pretty much sit just there. So that is a little bit unfortunate. But we could extend them. That would be a little bit painful unless, these headers, if these are headers, they'll just pop straight off. They are. Okay then. So, because these are essentially just headers, they're female headers that plug directly into here, we might even be able to just use some little jumpers that I have that can extend those cables, which would be awesome. Let me see what I got. Change of plans, again. This time, I'm going to try and fit the Arduino sitting sideways in here, behind the current battery pack, which would mean that we would plug our USB cable in from the side of the unit when we're sitting at it. I think that'll be okay, and we're still going to be close to the power. It means we can make all these connections here. I think that's okay. So let's do that. Pro tip, every time you think you've cut a cable the right length, you're wrong, double it. Okay, not double it, just add a bit more. It's always just a bit more that you're short. Luke. Now this is just some multi-core wire you get from J-Car. It's pretty basic stuff, standard stuff you use for most electronics. The wires that we're going to be soldering to on here are really tiny, so it's going to be a little bit tricky for us to strip them, but I'm going to show you a pro trip for stripping wires. When I say pro tip, I mean buy yourself one of these. This has to be one of my favorite tools. It's not like the favorite tool, but it's definitely up there. Essentially what we do, you just grab this in here, and you just click. Look at that. You got a stripped wire. Oh. Saves so much time and effort of sitting here with these ones and trying to do this and then pull on it and then you get it wrong, actually snip through the cable. So yeah, would highly recommend getting some of these. They're like, I don't know, 15 bucks or something. Just buy it, just do it. You'll never regret it. There's a few different types. These ones are pretty good though. So what we're going to do is just essentially strip all the ends of our cables before we make our connection. Strip. Strip. Beautiful. Strip. Beautiful. Strip. And strip. 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 And look, for those who think they're a little bit advanced, you can do 2 cables at once. Look at this, ready? I'm going to wire these cables up first, we've got the right cable lengths, and then we can work on the Arduino side. So I'll do all this side, make these joins all beautiful and pretty, and then we can work on the Arduino side. Just want to make sure that when we're doing the bringing these to ground and stuff like that, we're not actually affecting the circuit that's already there, which may be a bit of an issue, but it's a learning experience. We'll figure it out later. That is Future Corey problem. That's what that is. Future Corey problem. Future Corey has a lot of problems. He's got to sort out. He's got to sort his shit out. Got a Future Corey. Rightio. So before we actually do the soldering, another pro tip: put your heat shrink on before you do the joint. Before you do the joint. Every time. So let's get the soldering iron fired up. We can solder these joints together, run these cables, connect with the Arduino, and it'll be good. So that's one connection done. So what I'm going to do is maybe just twist these together. Rightio, so now that we have all of our wires hooked up to our piezoelectric discs, we can actually get those hooked up to our Arduino finally. So how we're going to connect those is via some male headers. These are pretty cool. You can snap them to wherever you need to go and they'll just plug straight in. So we can use this like a little plug. I've decided that I'm going to wire up the resistors, so the 1 mega ohm resistors which are across our terminal, so between ground from like the board and between the positive mosquito. Gotta love Australia. Alright, where was I? I've decided that I'm going to wire up the 1 mega ohm resistors and the wires to the Arduino using a bit of proto board. So essentially it's just a board that has holes in it, that has just some little copper pads on it which we can solder to super easily. That's going to mean that we can actually connect this up to the Arduino really easily and take it off using some male headers. And also means we can get the wiring nice and neat so we know that nothing's going to short, which is good because shorting is bad. Top tip. You can actually use a lot of the time the wire that you cut off the legs of components, so say these resistors, they've got these long legs that we're going to cut off anyway. We can use those to run along some proto board to actually link up a whole heap of things. Say for this ground where all of these need to be connected together, we run a little strip of wire along there, and it makes the soldering a lot easier rather than trying to dab a heap of solder in there to jump across between the holes. So there you go. Top tip: when you're soldering things like headers and they're going to be going into something, it's really good to always make sure that you actually put them into that thing first. Maybe dab them on with a little bit of solder in one spot to hold them in the right position. Helps to line things up and just make sure that they're actually going to fit, rather than doing all this work and then it's, you know, oh crap, I've got to like force these pins in and they snap. Cool. So with our little board done up, we've got the resistors on there in line. What we're going to do is actually be soldering these wires to each one of these resistors. But to do that, we're going to have to make sure we get them actually fed through here before we solder that on. Otherwise, we're going to undo everything and start again. So all of the cables are now wired up to our little board that we've done up. And I've just realised I've done goofed. So this little panel here is supposed to sit on the back of this, which is then what connects this to that. But now we've got wires going through there. And I've soldered them on. Damn it. So what we're going to do, I'm going to cut just a little groove in there so we can slip the wires in. You won't actually see this because it sits on this anyway, so you won't see it from the front. Should have thought that out there. I was even going to have it so I had plugs that you plug them in and so you can take each cable on and off if you need to later, but I thought, nah, it's fine. We don't worry about it. We should have worried about it, but anyway, it's fine. I'm going to cut this, or report back in a sec. Okay, so I've done goofed again. Where we're putting this Arduino inside here, the USB was going to come out the side here, which is going to be awesome. What I didn't take into account was that this actually sits into this top piece with this recess here, which means that our USB cable has to go through there somehow. And that's not going to happen. So I got to figure out how to fix this. What I'm thinking, what we can do, is this back piece here actually comes out. So maybe what we can do is just mount our Arduino this way. And then that'll just stick straight out the back of the unit next to where the batteries were. I've rewired this battery pack because this one on here was dead from ages ago. So maybe what I'll do is I'll just cut that off, stick the batteries there as well. This whole thing can have an open back. That's not too bad. So another pro tip for any of you guys playing along at home: if you finish the project and you're left over with a few screws, you know you've done it right. So if you haven't, just make sure you take it apart, put it back together again a few times, and repeat that until you've either missing a screw or you've got an extra one left over. Then you know you're spot on. So what I've done is set up a separate Arduino with a piezoelectric disc that I've just soldered up myself, which means that we can actually test the audio interface with the computer. So I followed a tutorial by, I keep forgetting his name, Kale. Really cool guy. He does a lot of videos on like MIDI controllers. He makes his own. He does lots of audio interface type stuff. So definitely check out his channel. I'll put a link in the description below to the video that I kind of followed. When he did this, he actually did it to an output of an actual output MIDI jack, which means that he could plug that into his other audio gear, obviously. I don't have that luxury, so I'm going to do it via a USB cable from the Arduino. But to do that, it's a little bit tricky on the Arduino Unos because they don't have, I suppose, like the native support for that. So what you actually got to do is re-flash one of the chips that's on there that actually handles the serial communication so that it disguises itself or shows up as a MIDI device when you plug it into your computer. So it's not too bad. I'll put some links in the description below of how you can actually do that. I'm just going to go ahead and show you essentially what the output of that is. It's pretty simple. So let me just do this. Audio here. So what I've done is I've mapped it to some software called Fruity Loop Studio. It's a really cool little, like, beat matching, kind of beat creation software where you can, chuck some sounds in there and do some cool stuff. So what we'll see is as I click this, it makes some noise, which is awesome, and it's also pressure sensitive. So if I tap lightly, you get little sounds. If I tap hard, that's exactly what we want, right? Awesome. So what we've done is mapped each. Whoop, that's funny because we've got it to a bench top. That's cool. Let's leave the audio down for now. Alright, so yeah, I've mapped this piezoelectric buzzer. Just press smack any random buttons on here whenever it's activated. So what I'm going to do now is upload the same code to the Arduino that we've put inside the drum kit, and then we should be able to map each one of those to a separate sound. So we have some of them set up as like tom drums, one as the bass, two cymbals on there, and then we should have a fully operational drum kit. So I've gone back now and remapped all of our drum sounds to match the MIDI inputs that we get from each of the different drum pads. Let's give this thing a go. There we go. Not too bad, bit of a fun little project. Let's ramp it up a little bit further though. Yeah. Thanks so much for watching. Hope you enjoyed this little project. Let me know if you liked it in the comments below, and give this video a like. It really, really means a lot to me. And it really helped me to kind of figure out where I want to go with these videos and how often to put out content. If you have any ideas for projects that you'd like to see, let me know as well. I'm hoping to put out videos a lot more regularly now that university is over, so every 1 to 2 weeks I'm hoping to pump out another project. So keep an eye on the channel, put the bell on if you want to get notified for upcoming videos, and I'll see you next time. Cheers!